dear students. I am Dr. Shikha Pandey, Associate Professor from Institute of Aeronautical Engineering. In this lecture series of this solid waste management subject, today we'll discuss about the type of incinerator. So in last class, I have discussed about the incinerator and how this incinerator will work and what are the different criteria that should be utilized while designing an incinerator. So this will be the whole picture that is related with the solid waste management that I have already discussed like this. This will be the whole picture, like the functional element of municipal solid waste management. So for this municipal solid waste management, it will start with the word that is waste generation, generation of waste from the household. After generation of waste from the household, first collection method of the waste is there, that is called as primary collection. With primary collection, after the collection of the waste, its on-site storage is required, that is called as either waste handling or it's a safe storage. And after its secondary collection will have two words, that is transfer and transport, and processing and transformation. So at we are present at that position, that is called as transformation of waste. Transformation of waste, how this waste is transferred and how it will be transformed from its a contaminated category to uncontaminated category, how the waste would be disposed, and after its transportation, its a final transformation, its a final disposal practices, what disposal practices has been adopted for that particular waste. So in this transformation technique, we are studying this topic, that is incineration. As now today I will discuss about the type of incineration. Okay, so now first of all, let's start the topic with the first introduction of the incineration. So incineration, the meaning of incineration, what is the exact meaning of this incineration? Incineration is the process of burning of hazardous waste material at a high temperature, and that will be enough to destroy any contaminants. This is called as incineration. Incineration is the process of burning of hazardous waste at a very high temperature, and with that much high temperature, the hazardous waste will be converted into a non-hazardous waste, and with that much amount of temperature, that is going to destroy the contaminants already present in the waste. So the waste that is hazardous in nature, and so to remove its contaminants, this methods has been adopted. Remove its contamination, and incineration is conducted in an incinerator. An incinerator chamber is there. In that chamber, incineration is conducted. It is we can call it is like a type of furnace which has been designed for the burning of hazardous material in a combustion chamber. So this incineration is conducted inside a chamber. That chamber is called as incinerator, and in that incinerator, this has been like a burning of hazardous material is there in that combustion chamber. All hazardous material is burned inside this combustion chamber. So fuel will be there, and from fuel, here you can see that contaminated waste, it act as a feed. So with the feed, the fuel will be passed from this chamber, and in the combustion chamber, it starts burning at a very high temperature. And then what happened, the gases to air pollution control devices there, already some devices has been installed to clean these gases, so to prevent air pollution due to this burning of this waste, because these are hazardous waste, this will contain many contaminants. So if you will burn this waste at that much of high temperature, so maybe the contaminants, the contaminants is there in the waste will be enters into the air, and that toxic will be released into the air. So to avoid this problem, some devices is there, that devices has been installed to clean and purify the air. You can see this is the first combustion chamber, and this is the second combustion chamber. In first combustion chamber, some ash will be produces. That ash will also contain some contaminants, and this air will also contain some contaminants. So where air will be purified with some electrostatic precipitator devices. Okay, so now comes to the types of incinerator. So first of all, we are going to discuss about the moving grate incinerator. Moving grate incinerator means what? The conventional mass burn incinerator based on the moving grate it will consist of a layered burning of waste of on the grate that transport the waste through the furnace. Means what happen in the moving grate incinerator, some layers are there. On that layer the waste starts burning. On the moving grate, the it consists of a layer. That layer will be burning of waste on the grate that transport the waste through the furnace. So this layered burning of waste on the gas, it will transport, it will transport the waste through the furnace, through the furnace. And the conventional mass burning incinerator are there. These are the incinerator. That incinerator is the conventional, means conventional mass burning methods are there, and it will be work on a moving grate, and the grate is there, moving one grate is there that consists of a layered burning of the waste on the grate, and that transport the waste to the furnace. And the overhead crane is there, one crane is there, the crane will feed the waste into the hooper where it is transported via the tubes to the grate in the furnace. And on the grate, the waste is dried and then burned at a high temperature while the air is supplied. So you can see that this is the actual picturization of moving grate incinerator. This picture will show that first of all, you can see that here the refuse vehicle will come and this storage hoopers are there, and this crane is there. The crane is putting the waste, and this is the chamber waste chamber is there. Crane is putting the waste, and with that crane it will puts here also, and one chute is there. The chute will be open, and by the opening of the chute the waste will be putting there, and from there the driving grate is there. Some fan is there and driving grate is there. With the tubes it will pass through the burning grate, and furnace is there, and charging hooper is there. So by the burning grate, and that waste will be goes to the here only, that is the residue removal. And combustion chambers are there here only. Combustion chamber is there. In that combustion chamber, that waste will be burned in the combustion chamber. Waste will be burning is there in the combustion chamber. And the burning of there, some ash will be removed from here, and ash will be collected, and that is called as fly ash removal. And with the combustion chamber, next process will be there, that is gas cleaning arrangements. Like some devices has been there, that device will clean the gas. It will fume gases. And next is that fan has been there. Okay, so this fan is working on the principle that fan will remove the contaminants from here only, and with that stack it will be going out. This waste will be going out. With this stack, waste will be going out. This will be happen. So this is the picturization of the moving grate incinerator. How this moving grate incinerator will work? See, this is the drying grate is there, and burning grate is there. On that grate, that waste will be burned, and it will and the residue will be there. That residue will be collected here, and fly ash removal one opening is there. And in the combustion chamber again it will be burned, waste will be burned. And this is the actual picturization of moving grate incinerator. Now comes to the next process, that is about the incineration process. So how this incineration process will happen? It will be like the ash including non-combustible waste fraction. Some this ash is there, and some of the non-combustible waste fraction is remains left over in that waste fraction. So it will leaves the grate via the ash tubes, and the bottom ash or slag drops from the end of the grate into the water trap of the slag pusher. The slag is cooled by the contact with water, and a large piston pushes the slag to the conveying system. So this will be the next process that happens in the rotary kiln incinerator. Those waste which will remain non-combustible fraction, they will be leave the grate by the ash tubes, and the bottom ash or slag drops from the end of the grate into the water trap of the slag pusher, and the slag is cooled by the contact with water, and a large piston pushes the slag to the conveying system. That slag is cooled by the contact with water, and a large piston pushes the slag to the conveying system. And the fine particles are there, that fine particle and material with a very low melting point, it may drops through the narrow gaps between the elements of the grate, which constitute a minor part of the solid residue, like 1 to 15%. This is like 1 to 15% of the ash. The fine particle and material with a very low melting point, the very fine particles are there and some material are there, they with a low melting point, it may drops through the narrow gaps between the elements of the grate, which constitutes a minor part of the solid residue, that is 1 to 5% of the gases. And the flue gas from the furnace consists of minor part of the ash and the fly ash. So what happened then next, the flue gas are there, some from the furnace, the flue gas are coming, and that is consist of some very small parts of ashes and fly ash. This flue gas will consist of furnace, that will be consist of minor part of ash and some minor part of ash and fly ash. The flue gas from the furnace, the flue gas that is coming from the furnace will consist of very small parts of ashes and fly ash. So this is the next process of the incineration. The ash including non-combustible waste fraction that leaves via the ash chutes, those which will be non-combustible, which will be remain, that passes through the acid tubes. And the bottom ash or slags, the bottom ash which will be deposited at the bottom at the drop down center, and from the end of the grate into the water traps of the slag pusher. And then what happened, the slag is cooled by the contact with water. Then this slag will going to be cooled by the contact of water, and a large piston is there that is pushes the slag to the conveying system. And through that waste will come, and with the piston that is pushes towards the conveying system. And some fine particles and material are there with a very low melting point, that may drops through the narrow gaps between the elements of the grate, that is going to be dropped down narrow between the elements of the grate, that constitutes a minor parts of the solid residue, that may constitutes a very small parts of the solid residue, that is 1 to 5% of the ashes, 1 to 5% of the ash. And the flue gas from the furnace consists of minor parts of ash and fly ashes. The some flue gases are there that is from the furnace, that consist of very small part of ash and some fly ashes. Now we'll discuss about the what is the advantage, what is with the benefits, and what will be the disadvantages associated with this moving grate incinerator. Advantage is that it can accommodate a large variation in waste composition and in heating values. So what happen, it is going to benefit like that it can be accommodate very large variation in waste composition and in heating values, and it can be built in a very large unit, because this type of great incinerator can be make a very large unit. You can make it for a big cities also. And thus the plant's installation cost is like high, and their maintenance cost is also high. So if we talk about the cost benefit, it is really costly. Cost benefit it is costly. And advantage is that it can accommodate large variation of waste composition, means how much variation of waste is there, that can be accommodated with a high heating value. And it can be built a very large unit, like up to 50 tons per hectare. Because of that only, obviously, if it will be a large unit, if it will be accommodate mixed type of waste, then obviously it will be having a very costly affair, because their cost, and it is a very costly also. So this is the disadvantages related with this incinerator. And the next type of incinerator is the rotary kiln incinerator. So in this, what happened, this is also a mass burn incinerator based on the rotary kiln, consists of a layer burning of the waste in a rotating cylinder. In a rotating cylinder, some moving grates are there, and the layer of burning of waste is there in a rotating cylinder. The material is transported through the furnace by the rotation of the inclined cylinder. So this material is transported to the furnace. What happened? The material is transported to the furnace by the rotation of the inclined cylinders. inclined cylinder rotation will make transport of the waste toward the furnace, and the rotary kiln is usually refractory lined but can also be equipped with water walls. This rotary kiln is like refractory lined, and it can also be equipped with some water walls, and diameter of the cylinder may be 1 to 5 meter, and length is 8 to 20 meter. So this is about the rotary kiln incinerator. Is again a incinerator. Only the difference is like that it consists of layered burning of the waste in a rotating cylinder. So what happened inside a cylinder type of cylinder type of shape is there, and inside that shape it consists of layered burning of the waste in a rotating cylinder, and the material is transported to the furnace by the rotation of the inclined cylinder. Material is transported to the furnace by the rotation of the inclined cylinder, and the rotary kiln is usually refractory lined but can also be equipped with water walls. And next is that the diameter of the cylinder may be 1 to 5 meter and length is 8 to 20 meter. So you can see this is the picture is there in the cylinder is there in that cylinder, that rotary kiln is there. So the capacity should be within the range of 2.4 times per day to 480 times per day, and the kiln rotate with the speed of typically 3 to 5 rotation. This kiln will rotate with the speed of typically 3 to 5 rotation per hour. The excess air ratio is well above that of the moving grate incinerator and the fluidized bed. What happened? The excess air ratio is there, that is well above that the moving grate incinerator and the fluidized bed. The energy efficiency does not exceed 80%. Only point is that it will not exceed 80%. This energy efficiency will not exceed 80%, and the kiln rotates with the speed of typically 3 to 5 rotation per hour. The excess air ratio, what happened, the excess air is there, that excess air ratio is well above the moving grate incinerator and the fluidized bed. The energy efficiency does not exceed 80%. The capacity should be between range of 2.4 times per day to 480 times per day, that is 0.1 tons per hectare to 20 tons per hectare. The kiln rotates with the speed of typically 3 to 5 rotation per hour. Now comes to the next point, what happened to this rotatory kiln incinerator, as the retention time of the flue gases usually is too short for a complete reaction to take place. Actually, its retention time is very less to take a complete reaction to take place in the rotary kiln itself. The cylinder is followed by an after burning chamber which may be incorporated in the first part of the boiler. That is followed by an after burning chamber which may be incorporated in the first part of the boiler. As the retention time of the flue gas usually is too short, as the retention time, what happened, retention time is there in the flue gas, that will be very short for complete reaction to take place. That timing is very much short for complete reaction to take place, and the rotary kiln itself, and the cylinder is followed by an hour and after burning chamber which may be incorporated in the first part of the boil. The rotary kiln may also be used in the combination with a moving grate, where the moving grate forms the ignition part of the rotary kiln forms the burning out section. So the rotary kiln is there, that may also be used in the combination with the moving grate. The rotary kiln can also be used with the combination with the moving grate, and what happened here, the moving grate forms the ignition part of the rotary kiln forms the burning out section. See, this is the picture of a rotary kiln incinerator in India. It has been adopted in India also. Next, the advantage and disadvantage. What happened? It will be similar like that of moving grate incinerator, but the energy efficiency is lower than the moving grate incinerator. The efficiency is only 80%. That's why it is not much efficient. And the disadvantage is that the plant installation and maintenance cost is relatively higher than that of moving grate incinerator. It is costly also, and the rotary kiln may be rarely used for new MSW incinerator plant with high heating values waste. It will be rarely used for new MSW incinerator plant with very high heating values. So these are the advantage and disadvantage associated with this rotary kiln incinerator. Its efficiency is less when we compare it with the moving grate incinerator. And it's again, its installation and maintenance cost is also high than that of moving grate incinerator. Rotary kiln may be rarely used for the new MSW incinerator plant with high heating values waste. Next type is the fluidized bed incinerator. Incinerator works on the principle where solid particle mixed with the fuel are fluidized by air. What happen in this fluidized bed incinerator? It will work on the principle where solid particle mixed with the fuel are fluidized by the air. All solid particle is mixed with the fuel and fluidized by the air. And the by fluidization, what happened? The fuel and solid are suspended in an upward air stream, thereby behaving like a fluid. So, with the fluidization, the fuel and solids are suspended in an upward air stream, and this will be behaving like a fluid. The reactor usually consists of a vertical refractory lined steel vessel containing a bed of granular material such as silica, sand, limestone, and ceramic material. So this is three terms is there. That are the three type of material are there. That material is used in this reactor. This is like it usually consists of a vertical refractory lined steel vessel containing a bed of granular material such as like silica, sand, limestone, and ceramic material. And these are the some of the materials are used in the reactor for the vertical refractory lined steel vessel containing a bed of granular material. And this is the picture of this fluidized bed incinerator. Now comes to the its actual working, how this has been installed in the Japan. You can see in the picture. And the fluidization of the bed is ensured by the air injecting through a large number of nozzles in the bottom of the incinerator. Large number of nozzles is there in the bottom of the incinerator, and it is causing a vigorous agitation of the wet material, in which the incineration of waste takes place in the close contact with the bed material and combustion air, allowing relatively low excess air level and high thermal efficiency. So this is about the fluidized bed incinerator. The fluidization of bed is there, and that will be ensured by the air injecting, and with a large number of nozzles are there. With those nozzles, they are injecting the air in the bottom of the incinerator, and they are causing a vigorous agitation of the bed material, in which the incineration of the waste take place in close contact with the bed material and combustion air, allowing relatively low excess air level and high thermal efficiency. Means low or and excess air level, and next is the high thermal efficiency. High thermal efficiency. The fluidization of the bed is ensured by the air injection through a large number of nozzles in the bottom of the incinerator, causing a vigorous agitation of the bed material, in which the incineration of the waste take place in close contact with the bed material and combustion air, allowing relatively low excess air level and high thermal efficiency. So this low excess, low and high air level is there with a high thermal efficiency. Now comes to the advantage and disadvantage that is related with this fluidized bed. So now let's discuss the advantage, benefits, and disadvantage that is associated with this fluidized bed incinerator. So first of all, advantage, like the benefit associated with this fluidized bed incinerator: reduction of dangerous substance in the fluidized bed reactor. What happened? There is a reduction in the dangerous substances in the fluidized bed reactor. Flexibility regarding low quality fuels and cost. Flexibility is there, that will be regarding low cost fuels, and low quality fuel will be there. NOx generation may be low due to relatively low and well controlled combustion chamber. This NOx generation is also low because of the less and well controlled combustion chambers. The burnout of flue gas and particles is usually good due to long residence time of the flue gas in the freeboard above the fluid bed. So this is again a very good advantage. Benefit is like the burnout of flue gas and particles is usually good due to long residence time. Long residence time is there, so the burning of the flue gas and particles is usually good, and it is free above board above the fluid bed, and this will be like time of the flue gas in the free boards above the fluid bed. Capital and maintenance cost is relatively low. The maintenance cost and the capital cost is obviously low, and that's why this type of fluidized based incinerator are most acceptable, because they have more disadvantages if we compare with the other, and their maintenance cost, capital cost is also less, because it will be first advantage is that it will be like reduction of dangerous substance in the fluidized bed reactor. Flexibility regarding low quality fuels and waste. Some flexibility is there which will be regarding the low quality fuels and cost. NOx generation may be low due to relatively low and well controlled combustion chamber. NOx generation is low because of the relatively low and well controlled combustion chamber. The burnout of flue gas and particles is usually good due to long residence time of the flue gas and the free board above the fluid bed. Capital and maintenance cost is low. So these are the 5 points that has been the benefits of this fluidized bed incinerator. Now comes to the disadvantage. Disadvantage is like demanding pre-treatment are required for smooth functioning. A pre-treatment is there before introducing the waste into its combustion chamber. Pre-treatment is required, either shredding or it is a segregation. Something will be required. Primarily, it is useful for the homogeneous waste type, which include liquid waste too. So it will be mainly it will be homogeneous. It will be useful for homogeneous waste type, that included liquid waste too. So only two disadvantages there for this fluidized bed incinerator. Mostly, if we talk about the cost, it is a cost effective, not much costly also. NOx generation is relatively low, and it will be under control by the combustion temperatures. The burnout of the flue gas and particles is usually good, because the burnout is also good, because their residence timing is also more as compared to both different that type of incinerator. So the residence time is also more, the burnout timing will be there, and they are their nox generation is low in this type of incinerator. And next is there is a reduction of the dangerous substance in the fluidized bed reactor, and some flexibility is there regarding the low cost fuel and cost, and the and maintenance cost is also low. So there are lots of advantages and benefits is related with this fluidized bed incinerator. Some disadvantages is required only the waste pre-treatment is required, and it will be primarily useful for homogeneous waste, which included liquid waste too. So mainly it will be benefited for the homogeneous waste type, that is going to include liquid waste too. So these are some of the advantage and disadvantage that has been associated with the fluidized bed incinerator. So we have discussed moving grate incinerator, kiln, rotatory kiln incinerator, and fluidized bed incinerator. So among the three types of incinerator, this fluidized bed incinerator will be best, because their advantages will be more. And what happened, there is a reduction of dangerous substances in the fluidized bed reactors. Flexibility is there, that is regarding low quality fuel is also less, and the NOx generation may be low due to vertical low and well controlled combustion chambers. The burnout of the flue gas and particles is usually good due to long residence time of the flue gas in the free boards above the fluid bed, and the capital and maintenance is cost is relatively low. So these are some of the advantages that is very much beneficial for this fluidized bed incinerator. Only two disadvantages is there, that is first is like it will be some pre-treatment is required for the waste smooth functioning. Primarily useful for the homogeneous waste type, which included liquid waste too. So this is the we have discussed about the incinerator, types of incinerator. So these are some of the examples of some of the books, textbook, which you can refer for its depth study, for more study of this type of incinerator and the incinerator functions also. So now I'm going to conclude my lecture. I have discussed about the incinerator. Like in last class, I discussed about the incinerator. Incinerator is nothing but it is like an incinerator furnace is there. In that furnace, hazardous waste will be burned out to remove its contaminants, and some air control devices is also there, and some flue gases will also be collected to avoid that to entry of that polluted air into the directly to the atmosphere. So in this lecture, I have discussed about the types of incinerator: fluidized bed incinerator, moving grate incinerator, and kiln type incinerator. Among all these three type of incinerator, the fluidized bed incinerator will be best because their maintenance cost is also less, and they will be work more efficiently than other type of the incinerator. So now at this point I'm concluding my lecture. So if you have any queries or any question regarding this lecture, you can write in the comment box, or you can mail me on my given mail id Shikha. You can mail me on my given mail id shikha.pandy@gmail.com. So thank you for today's lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.